In September 2026, NASA will launch the most powerful wide-field space telescope ever built. Not pointed at one star, one galaxy, one corner of the sky, but scanning hundreds of millions of galaxies simultaneously. A machine so capable it may force us to rewrite the rules of physics, discover thousands of new worlds, and possibly find evidence that we are not alone. This is the Nancy Grace Roman Space Telescope, and this is why it changes everything. To understand why Roman matters, you need to understand how recently we got the universe completely wrong. For most of human history, astronomers believed the cosmos was small and centered on us. The stars were fixed. The universe had edges. It was tidy, orderly, and designed with humanity at its heart. Given the tools available, that was a reasonable conclusion. Then, in 1923, astronomer Edwin Hubble was working at the Mount Wilson Observatory in California, staring at photographic plates of a hazy smudge called the Andromeda Nebula. Scientists believed it was simply a gas cloud sitting inside our own Milky Way, nearby. Local, ours. Hubble spotted a pulsing star inside that smudge, a Cepheid variable, and used it as a cosmic measuring rod. The number that came back stopped him cold. Andromeda wasn't inside the Milky Way. It was 2.5 million light-years away. That hazy smudge was an entire galaxy, as vast and ancient as our own. And if Andromeda was a galaxy, so were all the other smudges. Hundreds of billions of them, in every direction. Hubble kept going. He measured the motion of those galaxies and discovered something almost impossible to process. They were all moving away from each other. Not flying through space. Space itself was stretching. The universe wasn't static and eternal. It was expanding. And it had a beginning. We were not at the center of everything. We were a footnote. The logical next step was obvious. Put a telescope above the atmosphere. No air distortion, no light pollution, just raw, unfiltered starlight. In April 1990, NASA launched the Hubble Space Telescope. It was the most expensive scientific instrument in history, and almost immediately it failed. Hubble's primary mirror had been ground to the wrong shape, off by less than the width of a human hair. The images came back blurry, unusable. Congress was furious. The press called it a punchline. Then in December 1993, astronauts launched into orbit and repaired it by hand, in space. One of the most audacious missions ever attempted. When the corrected images came back, scientists wept. In 1995, astronomers aimed Hubble at a patch of sky near the Big Dipper so dark that colleagues called it a waste of telescope time. They held it there for 10 consecutive days. That apparently empty sliver of black came back filled with 10,000 galaxies, each containing hundreds of billions of stars. In a patch of sky you could cover with a grain of sand held at arm's length. The universe wasn't just bigger than we imagined. It was bigger than we could imagine. Hubble had limits. It was built primarily for visible light. But as the universe expands, light from the most distant galaxies stretches into infrared, a wavelength human eyes can't detect. The oldest objects in the universe were still hiding from us. The James Webb Space Telescope, launched Christmas Day 2021, was built to find them. Using a mirror the size of a tennis court and infrared detectors of unprecedented sensitivity, Webb peers all the way back to the cosmic dawn, the first few 100 million years after the Big Bang. And almost immediately, it started causing problems. Not technical problems, theoretical ones. Webb found ancient galaxies that were too big, too mature, too structured. According to our best cosmological models, they simply should not exist at that point in the universe's history. It was like discovering a fully formed oak tree growing where the seed was planted last week. Scientists haven't panicked, but the quiet conversations in cosmology departments have taken on a different tone. When your most powerful instrument keeps showing you things your best theory says can't exist, you have to start asking whether the theory is wrong. Which brings us to Roman. Hubble and Webb look deep and narrow. They fix on a target and stare for days, extracting extraordinary detail from a tiny region of sky. Roman does the opposite. Roman looks wide. Its field of view is 100 times larger than Hubble's, meaning one Roman exposure covers what would have required Hubble over 100 separate observations. In its first 18 months, Roman will map 500 million galaxies, discover thousands of exoplanets, and hunt for two of the biggest mysteries in all of science. Dark energy, the mysterious force accelerating the expansion of the universe, making up 68% of everything that exists, with no explanation for what it actually is. Roman's galaxy maps, measured across cosmic time, may finally reveal whether dark energy is constant or evolving, whether Einstein was right, or whether something deeper is at work. Dark matter, invisible, undetectable by any direct instrument, yet we know it exists because of gravity. Galaxies rotate wrong without it. Light bends around galaxy clusters in patterns that require vast halos of unseen mass. Dark matter makes up another 27% of the universe. Roman will trace its fingerprints across the cosmic web. Dark energy plus dark matter, 95% of the universe. Invisible, unexplained. Roman is going looking. The telescope isn't named casually. The name is a debt. Nancy Grace Roman was born in 1925, obsessed with the night sky from childhood. When she pursued astronomy, she was met at every turn by a world that had decided women didn't belong. Her academic advisor openly discouraged women from graduate work. When she applied for faculty positions, she was told there was no future for her in the field. She pressed forward. In 1959, she joined NASA, becoming one of the first female executives at the agency. There, she championed a radical idea, a permanent space-based telescope above Earth's atmosphere. Colleagues doubted it. Budget committees questioned it. The technology was barely conceivable. She pressed forward again. Nancy Grace Roman became NASA's first Chief of Astronomy and laid the programmatic groundwork that made the Hubble Space Telescope possible. Without her insistence, without her refusal to be told no, Hubble may never have been built. She died in 2018, 8 years before the telescope bearing her name will open its eye for the first time. Here is a thought that is equal parts beautiful and terrifying. The universe is not just expanding, it's accelerating. Galaxies are moving away from us faster over time. At some point in the far future, many of the galaxies we can observe today will be moving away faster than the speed of light. No signal, no light, no information from those galaxies will ever reach us again. They will be gone, not destroyed, just forever out of reach. A civilization existing trillions of years from now will look up and see almost nothing. Just their own galaxy, perhaps a handful of nearby ones. The vast cosmic web visible to us today will have vanished from their sky. They may conclude, with complete scientific rigor, that they are alone in a small universe. They will be wrong, but they'll have no way to know it. We live in a window. The universe is old enough for stars and galaxies and life to exist, but young enough that we can still see the full scope of what's out there. Roman is being built inside that window. Now, the question you've been waiting for. Roman was not designed as an alien hunting telescope. Its primary mission is cosmological, but it will observe thousands of exoplanets. And when a planet passes in front of its star, a fraction of the starlight filters through that planet's atmosphere. Different molecules, oxygen, methane, water vapor, absorb different wavelengths. Scientists can read that chemical fingerprint. Oxygen alongside methane is extraordinary. Those two gases react and destroy each other. They cannot coexist in significant quantities without a constant replenishment source. On Earth, that source is life. Photosynthesis produces oxygen, biological processes produce methane. Their stable coexistence is one of the strongest biosignatures we know of. Roman's exoplanet data could, in principle, point at a distant world and say, something is happening here that physics alone cannot explain. Not prove life, not send us a signal, but narrow the list. And discovering that we are not alone would be the most significant event in human history. Not just scientifically, philosophically, religiously, psychologically. Every framework we've ever used to understand our place in the universe would be stress-tested simultaneously. I'll ask you directly. Would you want to know? In September 2026, a machine the size of a school bus will be launched 1 million miles from Earth, open its eye, and begin to see, not deeply into one tiny patch of sky, but widely, across the full breadth of the observable universe. 500 million galaxies, thousands of new worlds, the invisible architecture of everything. Nancy Grace Roman spent her life fighting for the right to ask these questions. She never saw the answers. The telescope bearing her name will carry that work into a cosmos far stranger, far older, and far more populated than any of us yet understand. The universe is not waiting for us to be ready. It's just out there, expanding. Would you want to know if alien life was discovered? Drop your answer in the comments. Yes or no, no hedging. I read every single one, and I genuinely want to see where this conversation goes. If this one landed for you, subscribe. This channel exists for exactly these kinds of questions. See you next time.